Hi everyone, I am JVR Murthy. I work in the Arista engineering team on the wireless networking side. The cognitive Wi-Fi and its capabilities and features are known to many of you, and usually we have been talking about those. But today I am going to talk about what's under the hood, the solid foundation on top of which all these features are built. And also this platform fits perfectly into the overall cognitive management plane vision of Arista. So we have been enhancing this platform, optimizing it so that we can extract more out of it, build more innovative features. So I'll be talking about this platform, maybe the internal architecture and the building blocks of this platform. So I'll begin with the access points themselves. So the Arista Mojo access points are basically work without a controller. They take the full responsibility of the control plane and the data plane. So no wonder they also do a lot of stuff on the cognitive plane front. They are actually in the data path. They have access to each and every packet. And using that, we have exploited that fully to implement a lot of advanced features on the AP itself directly. In addition to the standard RF monitoring and other usual attributes that are extracted by access points and sent back, we also do a lot more on the access points themselves. As you can see here, initially when a client connects, .11 state machine is quite complex, so the AP start tracking the client's .11 state machine to a great detail. The basic association, authentication, all the way up to DHCP, DNS, portal. The access points also measure the latencies involved in AAA. How long does it take for the client to get the DHCP IP address? And they also track the roaming and steering of the clients for load balancing and other purposes. Similarly, once the client's connection is stabilized, it has the IP address. Now the next thing the APs do is to figure out what kind of client it is. So for that, they have a device fingerprinting module. Based on the traffic that they are seeing, they apply these fingerprints, extract the device type, OS type of the each wireless client. And then after that, the traffic starts flowing, so we want to know more about the traffic. So there is a flow tracker module that looks at each and every flow that's passing through the AP. The flow is initially passed to an application fingerprinting module that actually looks at that does DPI of the packets, and it assigns one of 1500 application types and protocols to each flow. And once that is done, then the flow tracker module takes on again and starts tracking that flow, collecting statistics about that flow and so on. And of course, the RF monitoring piece of it, which is essentially all the OSS, BSS counters, the APs actually send around 300, I think the text is missing here, but the APs actually send around 300 OSS, BSS counters back to the cloud, everything on the channel, the clients, the BSS and so on, across various dimensions. So all of this data is streamed in real time back to the cloud. And there is also an open config interface which will be fully available shortly. Using the standard gRPC, GNMI protocols, one can fetch all of this state directly. Any third-party system can fetch this state and build their own applications, their own backend logic based on this data. So the access points stream this much state, and there can be like thousands of access points per customer and thousands of customers. So what kind of cloud is required to handle that volume of data? Of course, a very highly scalable cloud platform is required.
Could you go back 1 second? Under RF monitoring, why is that blank?
He said the text was left off.
Oh, okay. Sorry, I was typing. Thank you, Sam.
Yeah, probably we'll update the slide deck and yeah. So coming to the cloud, actually being able to handle this volume of data from thousands of access points and thousands of customers requires a really scalable cloud, and that's what we have built here. There are multiple service tiers in the cloud. The main ones being the wireless manager service, which actually receives all the data from the access points. It validates the data, and then it basically does a lot of processing on the data itself. This is more like a homegrown software that can run in an elastic cluster of nodes. And once it's done with it, it puts all of this data, both the raw as well as the processed data, into Kafka streams for the big data cluster to get this data and then act upon it. The big data cluster itself has multiple components to it. Some of the high-level ones are shown here. The most important being the Spark cluster, which actually provides compute nodes to run complex jobs on top of this data. And after all that processing, the data is then pushed into a storage which is built out of HBase and Parquet files running on top of HDFS. And then finally, to access this data, there is a drill interface available, and the drill interface is used to query this data along various dimensions. And then this entire data, access to it is available in the form of REST APIs through the API layer, which is in itself a cluster. It has a load balancer in the front to handle the API calls and distribute the load. Every piece of data, every piece of information is available through APIs. And apps can be built. Our own main user interface called the Cognitive UI itself is built on top of this API layer. But these APIs are publicly available. Anyone can just take the APIs and build their own applications, fetching data out of this cloud framework. So essentially, this whole cloud big data framework that we have built forms the foundation of many of the cognitive Wi-Fi features, because they require the kind of processing and storage, being able to store massive volumes of data for like weeks together, historical data on RF, client fingerprinting, application fingerprinting, all those details. This framework provides that ability so that we can then use that to build innovative features on top of it. So coming to the data itself, which is the third important piece of this whole thing, we store comprehensive set of data, and our philosophy is just store everything, right? If we can think of some new information that we can extract, we just stream it and then we store it in the big data cluster. That's our philosophy. And there is a long list of things we store. It's very comprehensive, right from client failures, packet traces, client roaming and steering, voice video calls, application usage stats, RF related aspects, the RSSI of clients as they roam across the Wi-Fi space. I mean, anything you can think of, all of that is streamed and stored in this big data cluster. And also, being a cloud Wi-Fi company from the beginning, we have been fortunate to have most of the customers using the cloud, and hence access to real data sets over which we can we can apply the big data principles and the machine learning principles.
Out of curiosity, how does that fall apart when you don't retain data past 1 month? I think the big data picture looks really appealing if you go back a year, 2 years. I've been running this infrastructure for 10 years. Tell me how I've evolved.
True. So 1 month is the default right now. However, and it is tuned primarily from a cost perspective. However, based on customer needs, it's a parameter that can be tuned to even 1 year. The cluster itself doesn't, the big data cluster itself doesn't place any limits on this. This 1 month is something we have selected as the default value, and it can be changed on a per customer basis. So, and yes, you are right. If we can change it to say 1 year, then the kind of data that's available and the kind of value that can be derived will be much more when compared to if it is 1 month.
I think it'd be much more mainstream if it was greater than 1 month. Just I'm thinking out of my perspective, where I need to see like user trends, how many BYOD devices are on the network and stuff like that. 1 month seems a little small to gather enough information to form a good, or gather enough information to make a good decision on things. But
sure.
If you're looking at it from an MSP approach, right?
Perfect example.
Where you're cycling things on billing cycles
Absolutely.
over time, year over year, month over month, things like that.
That's an excellent point.
Or the education space where you do things, how do we look this semester versus last? How do we look, last opening academic, period, or scholastic year kind of thing?
And Scott and I were having this conversation earlier. A lot of this data, when we're looking at trending, right, we don't need to know per client per second when we're looking at trending, right? So the amount of data that we actually, when you start thinking past 1 week or past 1 month, the types of data that we need to keep versus the types of data that you might want in those, in that 1 month window is two completely different types,
Yes,
sets
agree.
of data.
Yeah.
So there's a lot of data that can be stripped for archival and still be able to answer all of those trend questions. Because I think after 1 month, that's what we're looking for is trending. We don't need to go back past a month for in-depth packet captures or anything along those lines, unless there was a specific problem.
John has a comment.
I'm still learning, so I'm going to ask some questions too. So the one issue is keeping the data for a month. That's for kind of archival, but you use all the data for training purposes. So the algorithm has looked at deeper than the 1 month. Is that true?
Yes, the models themselves are evolving over a period of time. So, for example, the baselines, right? They contain information from data which was before that 1 month as well. However, the data itself, by default, is lost after 1 month. However, that is a default parameter.
And is that the same true for also the packet capture data?
Yes, it's true. Yeah.
Thank you.
Yeah.
So with that baseline, though, will we still be able to go back and say 5 years ago, this was where we were at? Even though we don't have the data, we can still see that baseline. Or is that...
No, not really today. However, I think, again, coming back to the point made by you, right? We can roll some of this data in and then, think of storing it on a longer term. And I believe the platform itself is capable of holding much more than 1 month. It's just, something we have to probably...
I think that's a good point. Even if we want to store all the data, if we could keep trending data, that might be a smaller set for a longer period of time. That sounds like that would be pretty high value.
Bring it down to something so basic as
a more digestible set of data.
Well, you may want some more depth of information just than that, but I think what JD and I were talking about was, the ability to, even if it's something, from a cost perspective, right? Obviously, cloud costs are exponential based on storage and stuff like that, depending on the customer, et cetera. But even if there was some ability for us maybe to pull that data down before it gets dumped or whatever from the database, so that we could host that maybe in our own storage, on our own data center, something like that. And then maybe you guys help us out by facilitating a piece of software that would allow us to see that data in the dashboard outside of the cloud to still draw those conclusions upon if we need longer term storage.
Yeah, I think the data you keep in the cluster is just huge sets of metadata that's hard to understand, right? But if the reports and information generated from that data could be reduced and stored for a longer time or downloaded.
Because you look at it from
really good trending
from a perspective, right, of how big of a circuit does this customer need? What was the capacity in that area over a given time? And then you look at it from the side of working for a VAR, right, where we're trying to provide additional services and value to the customer of what else can we do on top of that, and looking back at that retained data, historical data, to determine pricing for the customer and things like that. So.
Yeah, right. Actually, a lot of raw data is available to download in the form of APIs and on the GUI itself. So that can be done today. Customers can download.
In Excel, you said?
Sorry?
Did you say?
APIs.
Oh, okay.
APIs and on the console. It can be a lot of the raw data itself can be downloaded, and then it can be stored offline. However, our own platform, the way the parameters are set right now, it's set at 1 month. However, as I said, I think increasing it from 1 month to 1 year, it's not that the platform itself is not capable of handling it. There are many other factors that go into deciding this by the default value, and it can be changed on a per customer basis.
Yeah, and you're no different than a lot of the other vendors that do the same type of thing. So it's not like we're picking on you guys. It's something that I think we've all looked at as an industry perspective of what do we need out of those products versus what do you guys need to just have the network operational and draw your conclusions from in a short period.
Okay, so we have access to all this data and then this strong platform. What can we do with it? Essentially, we can provide unprecedented visibility into the network, provide real-time 24/7 monitoring of the network, being able to troubleshoot issues by going back into the time, or provide more in-depth insights into what's going on in the network. Just to give you an example, say someone comes to the network admin and complains that 2 days ago I went to this building and then I faced some issues. I would not tell you at that time, but how does the network admin make sure this doesn't happen? So there is enough data here to trace back the steps taken by that specific wireless client 2 days back, what APs it roamed to, exactly at what signal it's been connecting with each of the APs, what was the channel load at that time on that specific, in the vicinity of the client, how many other devices were operating, what was the retry rate, all those parameters are available. And looking at all of those, a picture can be constructed as to what happened at that time that may have caused an issue for that specific user. Another example, I want to know as a network admin, in the last 1 month, what are the top applications in my network by usage? So that data is available. Or I want to know, are end users getting good experience, right? Like, tell me how many users in the past 1 week have not gotten a good link rate. So I say, I want to give an SLA to my end users that, everyone gets 100 Mbps link rate, speed of connection back to the Wi-Fi. Now tell me how many users haven't gotten that in the past 1 week. And so all of that data is available, and then once an issue is identified, there is more data to drill down and analyze as to what could be the root cause for that and so on. So this is one part of the whole availability of a big data platform and the real data set that comes with it. The other part is actually learning. With the learning usually is compute intensive, however with the availability of a big data platform and more importantly the real data set from the customers, learning algorithms can be applied on it to baseline key network parameters, understand how they are trending, learn client behavior to make sure that the actions taken by the system towards the clients is in tune with their behavior, detect anomalies in the network, and even automate some of the root cause analysis based on the learning algorithms. And I think we have done all of these as we'll show in the next session. But this is a key piece. Learning is a key piece, one of the key advantages of this whole platform and the real data that's associated with the platform. So having said all of this, can we say measure the voice video call quality of applications? As a sysadmin, voice is an important application in the enterprise. I want to know how those calls are going, what kind of experience are end users getting. Now with this platform and with all this data, can I provide that? The answer is yes, and actually we do that. This is a recent addition to Cognitive Wi-Fi. I'll spend I'll give you a very high level overview of how the platform is used to build this feature, and then we can go into more details in the next session. So as soon as a wireless client starts a voice call, the access point immediately detects a new flow, and then that flow is sent for classification. And if the flow is classified as a voice call, immediately the flow tracker starts maintaining some stats about it. It essentially divides the call into 30-second chunks, and for each 30 seconds, it computes a lot of character parameters, the most important being the average bit rate, the average packet rate, the variation in the bit rate and packet rate, the protocol of whether the voice call is using TCP or UDP, and then it also attaches a lot of RF parameters and other stats it can compute. Like for example, what was the RSS of the client within this 30-second period? What was the retry rate the client is experiencing? What's the link rate the client has? So it computes this record for each 30 seconds for that specific voice call, and it uploads the data back to the cloud. And all access points does this for all the calls that are going on in the enterprise in real time.
So is there a reason why you only decided to choose 30 seconds?
So if we could have divided it into like 1 minute or maybe 10 seconds. However, it's about, the idea is to divide the whole call into chunks of time windows and then measure experience within that each time window separately. So we thought 30 seconds is a granular enough window, but in theory it can be done for 10 seconds as well, or it can be increased to 2 minutes. So once this data is available to the cloud, so there is a pre-trained model available in the cloud that we have trained in the lab, and the cloud applies this model on each 30-second chunk on the call, and then it classifies that 30-second interval of the call into good or bad. So essentially if a call runs for say 20 minutes, it has 40 chunks available, and it classifies each chunk into good or bad. So it has 40 good or bad classifications for the entire call, and then it also gives an indication as to, out of those 20 minutes, are there pockets in between where the call quality was not good, and if so, what is the reason? So once this is done, then all of this data is pushed into the big data, where now you can slice and dice this data on multiple dimensions, on per location basis, per access point, per user, across all users, and the end result is nice high-level dashboards like this. In this dashboard, as you can see, there are total one Wi-Fi user is affected by Skype, one Wi-Fi user is affected by GoToMeeting, and so on. So, and then one can drill down into this, look at the exact calls that were made, at what were the parameters that were the RF characteristics of that call, to understand, like, if there was a negative experience, what is the reason for that negative experience.
And this dashboard is Mojo or CloudVision?
This is the Mojo dashboard.
Okay.
So this is just an example of the kind of features we can build with the powerful platform we have built. And so concluding, I think the Wi-Fi cognitive plane, it fits nicely into the overall Arista's broader cognitive management plane. It's a unique combination of intelligent edge access points, the big data in the cloud, as well as access to real customer data sets to really use machine learning and other advanced concepts. So,
are there plans to integrate the Mojo dashboard into the CloudVision product? If we can, is that on a roadmap of any time? Do we know what the status is?
I think what we're going to look at, I think what you see that Mojo did extremely well is focus kind of on the user experience and the client experience. From the CloudVision perspective and coming at it from the data center, it's more predictable the environment is with the server connection and the physical servers owned. I think as we see opportunities and requirements in the campus to do similar things, we have all the data and could add the appropriate dashboards into the CloudVision piece. So we're gonna, I don't want to call it cherry pick features, but where it makes sense over time and we get customer feedback to add elements, we'll do that. Obviously, things like topologies are pretty straightforward, and we'll get on that right away. But I think, you know, when two companies come together, there's one influencing the other. I would think the mojification of Arista is going to be a lot around what does it mean to a client, debugging a client experience all the way through the network, and pulling it back through that way. But I think you can see from this presentation, we've both taken this approach of streaming a heck of a lot of data into a database, and then I think Mojo's done a great job in the machine learning piece and figured out how to, you know, move that ahead and actually represent some consumable data as a result of that.
Okay. I think it's going to be interesting to try to marry that data that you have in the data center side versus what you have here from Mojo's cloud, because a lot of this data is analyzed with cloud architecture versus your data center, which a lot of maybe your customers have on premises. Yeah. So like you have, how do you marry the data where you stream data to the cloud, but then have to stream it back down to analyze that together with what you have in a data center to collectively come up with the full user experience?
There's some things that we do in CloudVision that don't require tons of data, but there are other aspects like tap aggregation that's streaming a lot of data, and you're trying to look at that, and that's what we're going to work through.
So to that point, and this may be more towards you, how much information, like, are we talking about when we're passing information from the AP, from a single, let's just say a single AP into the cloud? How much data are we talking about? Megabytes a day, a gigabyte a day?
I think it will definitely be in a few tens of megabytes per day.
Okay.
Yeah, at least that much.
So
however, it also depends a lot on the kind of environment you have.
Sure.
If there are like too many clients, or if there are too many state changes happening with respect to clients roaming around, then it will result in larger volume of data.
Yeah, I approached that because I used to do work with another wireless vendor, and we did a lot of EDUs. And I know just based on that experience and my travel across the states and, you know, other areas, in some parts of the country, bandwidth is a premium for some institutions. So places that have a limited size pipe, if we're talking about needing to occupy 30% of the pipe a day and just sending data back to your cloud, how do we overcome that so we free up space for the actual use of the network, which is user data, you know, requests and all to the web and stuff?
Right. Yeah. I mean, for that use case, the access points actually have to dial down, maybe compress the data, coalesce the data of multiple types into a single packet, and so on. Utilize the network more efficiently. So some of those optimizations already exist in the product, but we are continuing to build more such optimizations for this use case. Plus, also we have an interest of utilizing the bandwidth as efficiently as possible to pump more and more data back to the cloud.
So that's already happening dynamically.
To some extent, not everything is already implemented, but certain things are already there. For example, some data is coalesced in like instead of sending for each client separately, we bundle the data for several clients together so that we can send one packet. So some of those things are already happening.
So if I could just jump in.
I'm sorry, go ahead.
If I could just jump in on this topic, I do want to point out that if you really are in a highly bandwidth constrained environment in terms of your WAN bandwidth getting out to the internet or whatever, this stuff runs on-prem also. So in that kind of environment, I would certainly tend to support running the Wi-Fi management system as well as the wired management system on-prem so as to not contend for utilization on that critical, bandwidth-starved internet connection.
In that aspect, though, would we lose capability and functionality from the platform, though? Because if we're talking about a system that's based on big data and you're talking about needing this massive cluster size to do these calculations and algorithmic operations that you're talking about, we can't do that on-prem in a 2U box, right?
Well, there's no need to train the machine learning models on-prem because the training takes place in the cloud and then the parameters come down. So a lot of the functions work just fine. I think there are cases where a larger amount of capacity is needed to get certain features, but I think to a certain extent that can be offset by how much capacity are you willing to provide on-prem. So I think there's choices there.
So your on-prem environment essentially would just be a data storage, and then we could rate limit or something up to the cloud for processing? Maybe there's a disconnect in what I'm asking and what you're answering with, I guess.
Sorry, I don't think that's not one of the modes I have in mind. So I'm not imagining a mode where you would run primarily on-prem, but then sort of trickle a certain amount out to the cloud. I didn't mean to suggest that. I think that when you do an on-prem deployment, the data is being stored on-prem, and it's not going up to the cloud in that case. And to your question about whether you lose functionality, I'm not sure we support every feature without sufficient storage and processing in the on-prem cluster, but certainly all the core features are covered.
Okay.
Just to give you an example, the app QA feature, the voice call monitoring feature I just talked about, that feature, the actual machine learning, the classification part of it can even be pushed onto the APs. Actually, the access points can do that chunk classification, and the on-prem version can support, maybe not to the exact level as the cloud. Of course, given enough resources, even the on-prem version can support it. However, if the resources are limited, instead of maybe 1 month, you may have call data for 1 week, for example. So those modes already exist in the product. Any other questions?
I have a question. So Cloud Vision, I believe part of that was configuration management, being able to push out changes. Do you see that staying mostly with the Cloud Mojo dashboard for the access points, or pushing that into Cloud Vision and control over there? Do you guys have any plans on that?
Sorry, I just want to comment maybe a little more broadly. I've heard this kind of question several times now, and I find it a little confusing because it's sort of like if you're using Google, there's Google Search, there's Gmail, there's Google Calendar. People don't usually ask, well, can I use my calendar inside Search, and can I use Search inside Gmail? Sort of like, though they're different functions. And so I feel similarly about if I'm managing an access point, if I'm managing my SSIDs, if I'm managing I'm planning my floor plan for where my access points go, I'll be using wireless management functions, whether those are packaged into a VM with Cloud Vision or a separate VM on the same appliance. It's kind of a packaging issue that doesn't really affect the end user very much. And so there are certain functions where an integrated approach is extremely important. For example, end-to-end application troubleshooting. And there we're making a major investment to create a single application troubleshooting application that it combines the wired flow data with the wireless analysis and can pinpoint root cause anywhere from the Wi-Fi client to the server. Right, so that's an example of an application that benefits tremendously from a kind of a unified view of the network. And then the key there is to get all the data into one place, and whether that one place is inside Mojo Wireless Manager or whether it's inside CVP, again, doesn't really matter to the customer. What matters is that it's seamless operation, seamless user interface. So maybe if I can kind of ask you to reframe your question in that context, does that make sense?
Well, I guess that is some of the confusion is when you're managing the system from an end user, I think of it more from the support perspective. Am I going to be doing my configuration and management and looking at it over in the classic dashboard, or is it going to be integrated into traditional Arista tools? I think maybe that's where we're trying to come out with that, and how much of it is going to be, like, will I be able to manage my wired and wireless all from CloudVision? Is that the goal? Or do you guys see it still staying very separate? And I'm going to do my wireless things over here and see my wired infrastructure over there. I think that's why we maybe have some confusion on the questions.
Okay.
And there's also a little, you're a little unique. We get lots of single pane of glass. And so that was kind of is that where we're going? Or is it, I like your idea that they're two separate things. They should be separate.
People's obsession around single pane of glass always confuses me, for the reason that you actually want to do multiple things, and so you're going to need multiple ways of doing that. And what does it mean for it to be single pane? So to answer your question specifically, you talked about configuration. What I would say there is, if you're configuring routing protocols, you'll use a routing protocol configuration tool. Whether that's part of CloudVision or part of MWM won't be even a question you're asking. What you'll see is routing protocol configuration. Now, the reality is that's going to be in CloudVision because access points don't run routing protocols, right? So, but that doesn't matter to the customer. What matters to the customer is I've got an easy way to configure my routing protocols. And then likewise, you're configuring your SSIDs and your Wi-Fi client onboarding and your guest access policies and those sorts of things. You're doing that with pages for configuring those things. And those pages may be served by Mojo Wireless Manager. But again, that doesn't matter to you. What matters is that you've got a coherent way of tackling the problem. When you want to change your guest access policies, there's a simple, straightforward way of doing that. It applies across your whole network. So that may be entirely on the Mojo Wireless Manager side, but that doesn't seem important to me. What's important to me is that from the customer's point of view, there's a unified experience. And so insofar as the application, you're configuring segmentation and security policy. You want to define which classes of users can access which classes of resources. That spans wired and wireless. That's where we've got work to do, so that you can specify that policy in a single coherent way and have that apply to as access lists on switches, and also apply as packet filters in access points as appropriate, depending on your policies. Or the other example I already gave was application troubleshooting, where the problem might be the client keeps getting punted from AP to AP, and that's why they're having sort of poor service. Or it might be there's an overloaded server the processes can't keep up, and we can look at the receive window information in TCP and determine that server is not keeping up. That's clearly on the wired side. The customer doesn't care. The customer wants to troubleshoot the application. And that's where we have work to do to provide a unified, integrated application troubleshooting tool. Am I answering the question here?
I think sure, actually. I'm really not sure. The reason I say that is because you keep saying it doesn't really matter as far as where you go to do this, but I think for us in the field, we're going to want to know what parts of it are going to move more into this particular tool set or what's going to be here, and try to understand where those boundaries are, because you'll need to know where to go to look for it. And you mentioned a single pane of glass, that makes people twitch, but where do I go to do these different things, and where is the insight going to be?
So pick something easy like ACLs that are clearly applied to multiple platforms, right? Do you envision an ACL product that sort of transcends technologies regardless of where the ACLs get applied, or do you see that being done in a legacy Mojo product or in
I mean, it is a journey. The end goal is to unify these things together where it makes sense. A real easy example is inventory. So MWM has the ability to tell you what is connected. If you noticed on Ken's topology view, he kind of showed it there, but we also have a table we're building out that effectively tells you what is connected into the network. So this is work that we started that predated the whole Mojo discussions and so forth. So you have two different tables of what is connected into the network fundamentally. Should those be tied together? Absolutely. And are we doing that? Yes. You just want one table that sort of shows everything that is connected into the network as just a very simple example.
I think that's a great example. So this illustrates the principles I'm talking about. Inventory is a case where you really want to see all your stuff. You want to go to one inventory viewer to see your access points and a different inventory viewer to see your switches, because that's silly. And so what we have here is an example of that, where we've taken all of the inventory information from MWM, streamed that into CloudVision, and then CloudVision can show a single inventory view that includes your campus spine. You can include, this is a zoomed in view, but it also shows your data centers. It shows your VPCs in the cloud. And it also shows your access points and connected client devices, because we can pull that information. This is the beauty of state streaming. This is the beauty of federating management clusters, like I was talking about in my talk, to give you a single, to allow an application built in one cluster to operate over data sets that are partly streamed from other clusters. That's the beauty of this. It's right here. And so I think your example of you said access lists, but I would broaden that a little bit to say segmentation. You want to sort of define how your network's segmented, what classes of applications and users are there, what are the rules for how they're allowed to interconnect and interoperate. And you absolutely want that segmentation manager to run in a unified way on wired and wireless. And another example is flow tracking. You want to be able to see network flows. You want to see the flow as it passes through a wired switch, and then see the flow as it passes through the access point to the client. So that's another example where we plan to stream the flow data from access points into CloudVision where it can be visualized. But I guess the point I'm trying, so from the point of view of the user, I'm talking here about CloudVision and Mojo Wireless Manager. But from the point of view of the user, these aren't going to feel like separate things any more than, I don't know, Google Sheets and Google Drive feel like separate things. I mean, obviously they're different views. One shows you your files, another shows you your presentation, but they work together in a way that you'd expect as an end user. And likewise, a segmentation manager or a data center cross network designer or a topology viewer, they will all be functions of our integrated product, which you get to through a common launch page or splash page. And exactly where the web logic is implemented, where the data set resides, doesn't really matter to the end user.
I think you just cleared it up with that. I think that makes a lot more sense now.
Okay.